Anamorphic widescreen is a process by which a comparatively wide, widescreen image is vertically expanded to fit into a storage medium with a narrower aspect ratio. Compatible playback equipment can then recompress the vertical dimension to show the original widescreen image. This is typically used to allow one to store widescreen images on a medium that was originally intended for a narrower ratio, while using as much of the frame, and therefore recording as much detail, as possible. The technique originally comes from cinema. A film would be framed and recorded as widescreen, but the picture would be squashed together using a specially crafted concave lens to fit into non-widescreen 1.37:1 aspect ratio film. This film can then be printed and manipulated like any other 1.37:1 film stock, although the images on it will appear to be squashed horizontally as in a funhouse mirror. An anamorphic lens on the projector in the cinema corrects the picture by performing exactly the opposite distortion, returning it to its original width and its widescreen aspect ratio. The anamorphic lens on the projector is a specially crafted convex lens that corrects the picture so that the images on the screen look normal. The optical scaling of the lens to a film medium is considered more desirable than the digital counterpart, due to the amount of non-proportional pixel decimated scaling that is applied to the width of an image to achieve a so-called rectangular pixel widescreen image. The legacy ITU Rec. 601 4:3 image size is used for its compatibility with the original video bandwidth that was available for professional video devices that used fixed clock rates of ASMPTE 259M serial digital interface. One would produce a higher quality upscaled 16:9 widescreen image by using either a 1:1 SD progressive frame size of 640 x 360 for ITU Rec. 601 and SMPTE 259M compatibility, a letterboxed frame size of 480i of 576i. Similar operations are performed electronically to allow widescreen material to be stored on formats of broadcast on systems that assume a non-widescreen aspect ratio film. Many commercial cinematic presentations are recorded on standard 35mm 4:3 aspect ratio film, using an anamorphic lens to horizontally compress all footage into a 4:3 frame. Another anamorphic lens on the movie theater projector ultimately corrects the picture. See anamorphic format for details. Other movies are made using the Simplimat technique, which involves both filming and projecting without any expensive special lenses. The movie is produced in 1.375 format, and then the resulting image is simply cropped in post-production to fit the desired aspect ratio of 1.85:1 or 1.66:1 or whatever is desired. Besides costing less, the main advantage of the matte technique is that it leaves the studio with real footage which can be used in preference to pan and scan when producing 4:3 DVD releases. For example, the anamorphic encoding on DVD is related to the anamorphic filming technique only by name. For instance, Star Wars was filmed in 2.351 ratio using an anamorphic camera lens, and shown in theaters using the corresponding projector lens. Since it is a widescreen film, when encoded on a widescreen format DVD, the studio would almost certainly use the anamorphic encoding process. Monty Python and the Holy Grail was filmed in 1.851 ratio without using an anamorphic lens on the camera, and similarly was shown in theaters without the need for the decompression lens. However, since it is also a widescreen film, when encoded on a widescreen format DVD, the studio would probably use the anamorphic encoding process. It doesn't matter whether the filming was done using the anamorphic lens technique. As long as the source footage is intended to be widescreen, the digital anamorphic encoding procedure is appropriate for the DVD release. As a side note, if a purely non-widescreen version of the analog anamorphic Star Wars were to be released on DVD, the only options would be pan and scan or hard-coded 4:3 letterboxing. If you were to release a purely non-widescreen version of Monty Python, you would have those options, as well as the additional option of an open matte release, where the film footage that was never visible in theaters is restored to the purely non-widescreen DVD release. DVD video. A DVD labeled as widescreen anamorphic contains video that has the same frame size in pixels as traditional full-screen video, but uses wider pixels. The shape of the pixels is called pixel aspect ratio and is encoded in the video stream for a DVD player to correctly identify the proportions of the video. If an anamorphic DVD video is played on standard 4:3 television without adjustment, the image will look horizontally squeezed. Packaging. Although currently there is no labeling standard, DVDs with content originally produced in an aspect ratio wider than 1.33:1 are typically labeled anamorphic widescreen, enhanced for 16:9 televisions, enhanced for widescreen televisions, or similar. If not labeled, the DVD is intended for a 4:3 display, and will be letterboxed, panned and scanned. There has been no clear standardization for companies to follow regarding the advertisement of anamorphically enhanced widescreen DVDs. Some companies, such as Universal and Disney, include the aspect ratio of the movie. Below are how various companies advertise their anamorphic DVD movies on the packaging. Anchor Bay, enhanced for 16:9 TVs, includes aspect ratio in most cases. Artisan Entertainment, 16:9 full-screen version, or enhanced for 16:9 television. Since it became part of Lionsgate, the newer reissues include aspect ratio information on many titles. Buena Vista, enhanced for 16:9 televisions, includes aspect ratio. Columbia TriStar, anamorphic video, sometimes not labeled, includes aspect ratio. Criterion, enhanced for widescreen televisions, or 16:9, always includes aspect ratio. DreamWorks, widescreen format, enhanced for 16:9 televisions. Since acquisition by Paramount, aspect ratio included on formerly Universal distributed titles. Image Entertainment, enhanced for 16:9 TVs. Some titles include aspect ratio. MGM, enhanced for 16:9 TVs, or enhanced for widescreen TVs, includes aspect ratio since 2001, uses Fox's format since 2004. New Line Cinema, enhanced for widescreen TVs. Paramount Pictures, enhanced for 16:9. Trimark Pictures, widescreen. Since it became part of Lionsgate, reissues include aspect ratio information on many titles. 20th Century Fox, enhanced for widescreen TVs, or anamorphic widescreen, sometimes not labeled, includes aspect ratio. Universal, anamorphic widescreen, gives aspect ratio. Warner Brothers, enhanced for widescreen TVs, says scope for 2.35 or matted for 1.85 aspect ratio. Blu-ray video. Unlike DVD, Blu-ray supports SMPTE HD resolutions of 720p and 1080p with a display aspect ratio of 16:9 and a pixel aspect ratio of 1:1. So widescreen video is scaled non-anamorphically. An electrically coded video line is used in analog video transmission, recording and court displays. This can be sampled by a process called digitization, which in professional SD videotape recorders is done at a rate of 720 pixels per field. This relates to the bandwidth used in digital serial connections and have come to be inaccurately called rectangular pixels, so-called square pixels used to display 4:3 graphics and text on VGA CRTs are at 640 times 480, which excludes the sync pulses and blanking used in the field output. Therefore, to display a NTSC SD 4:3 capture of 720 times 480, you would have to crop the 8 pixels that are used for blanking off of each side and then anamorphic ally scale the result to 640 times 480. Squeezing to create a 16:9 frame only does a good job of delivering widescreen with reasonable quality using standard 4:3 equipment when the compressed bitrate is high enough to avoid compression artifacts being noticed, as they are in a low-rate MPEG-2 broadcast. Blu-ray also supports anamorphic widescreen, both at the DVD video D1 resolutions of 720 times 480 and 720 times 576, and at the higher resolution of 1440 times 1080. See Blu-ray disc technical specifications for details. Television. Major digital television channels in Europe, as well as Australia, carry anamorphic widescreen programming in standard definition. In almost all cases, 4:3 programming is also transmitted on the same channel. The SCART switching signal can be used by a set-top box to signal the television which kind of programming is currently being received, so that the television can change modes appropriately. The user can often elect to display widescreen programming in a 4:3 letterbox format instead of pan and scan if they do not have a widescreen television. TV stations and TV networks can also include active format description just as DVDs can. Many ATSC tuners can be set to respond to this or to apply a user setting. This can sometimes be set on a per-channel basis, and often on a per-input basis, and usually easily with a button on the remote control. Unfortunately, tuners often fail to allow this on SD TV channels, so that viewers are forced to view a small picture instead of cropping the unnecessary sides, or zooming to eliminate the window boxing that may be causing a very tiny picture, or stretching, compressing to eliminate other format conversion errors. The shrunken pictures are especially troublesome for smaller TV sets. Many modern HD TV sets have the capability to detect black areas in any video signal, and to smoothly rescale the picture independently in both directions so that it fills the screen. However, some sets are 16:10 like some computer monitors, and will not crop the left and right edges of the picture, meaning that all programming looks slightly tall and thin. ATSC allows two anamorphic widescreen SD TV formats which are 704 times 480. This is narrower than the 720 times 480 of DVD due to 16 pixels being consumed by overscan. See overscan. Analog to digital resolution issues. The format can also be used for full screen programming, and in this case it is anamorphic with pixels slightly taller than the width.